Hello everyone, in this video we are going to discuss the logic for the shortcut that I have shown in the YouTube shorts of my channel. You will be able to see it here. Okay, and now let us deep dive into this logic. So let me first give you a brief recap of the shortcut that I have mentioned in shorts. So the shortcut that I have said is that if you have a system of equations, okay, system of linear equations, okay, linear equations, okay, in three variables, okay, so that is x, y, z. And if you have the equations like a1x plus b1y plus c1z is equal to d1, okay, and if you have similarly for a2, b2, c2, and similarly for 3 as well, okay, if I just change these numbers, okay, if I change these numbers, we have a 2, okay, 2, 2, 2, and here as well, and here 3, 3, 3, and 3. Okay, if you have this system of linear equations, okay, and if you want to know the relationship between these coefficients when this system has infinitely many solutions, okay, when this system has infinitely many solutions, okay, then what you have to do is that, let me name this as E1, E2, E3, okay, E1, okay, E1, E2, and here will be your E3. And if you want to find out the relationship between each of these coefficients, which is coefficient x, y, z, and the constants, when the system has infinitely many solutions, okay, then the condition is that alpha times E1, okay, plus beta times E2, should be equal to E3, okay, where alpha, beta are assumed variables, okay, they are just temporary variables, and these variables can be replaced by any other two letters or any other two Greek letters like p, q, theta, phi, depending on the question, okay. So this is the condition for infinitely many solutions, okay, and this means that alpha times a1 plus beta times a2 should be equal to a3, and similarly you can apply the similar kind of equation for b1, b and c as well. Even with d also it will work, okay, like alpha b1 plus beta b2 is equal to beta b2 is equal to b3, then alpha c1 plus beta c2 is equal to c3, and alpha d1 plus beta d2 is equal to d3, okay. So for all these four constants you can apply, four types of constants you can apply this logic, okay. The logic behind this is very simple, that when you have a system of three equations has infinite many solutions, then one thing is quite obvious, that those three equations, which are actually three planes, they are actually just a single plane, right? If I draw a plane over here, then this will be a one plane, first plane, okay, and your second plane will be on top of the first plane, your second plane will be coinciding on the first plane itself, okay, right? The second plane will also coincide on first plane, and third plane will also coincide on second plane, right? Now if you see E1, E2, E3, they are actually plane 1, plane 2, and plane 3. If you see, E1 is also denoted by P1, E2 is denoted by P2 and E3 is denoted by P3, and for infinitely many solutions the logic is that P1 is identical to P2. Everything in terms of all sorts of parameter, P1 is identical to P2, and this is also identical to P3, and P3 is also identical to P1. Okay, so this is the only logic. Since this is the core logic, so what we can say is that if you have a plane P1 which is written in form of equation 1, and if you have plane P2 which is written in the form of equation 2, and plane P3 which is written in the form of equation E3, and P1 should be identical to, for infinite many solutions, P1 should be identical to P2 and this should be identical to P3. Okay, in this case what will happen is that if you extract their E1's x coefficient, you will get something like A3 by A2. Okay, so let me rearrange it properly. Okay, now if you extract the coefficients of x from E1, you will be getting A1, right? A1, and if you extract coefficient of x from E2, you will get A2. Okay, and if you extract it from E3 as well, you will get A3. Okay, and this should be equal to B1 is to B2 is to B3, and this should be equal to C1 as well, C1, C2, C3, and that should also be equal to D1, D2, D3. Why these ratios are equal? Because the planes are identical. So if you see equation 1 or equation 2 or equation 3, the coefficients and the constants are actually proportional to each other. So that's why this condition holds true for infinitely many solutions, and since this condition can't be violated, hence the coefficients and constants would be proportional to each other, and because of that reason only this logic holds true. Which logic? This logic. Okay, this logic holds true when it comes to infinitely many solutions. Now if I expand the first one, then this is what you'll be getting. Okay, so that's why for infinitely many solutions this logic holds true very well. Okay, now in the chart that I have shown you before, I only covered infinitely many solutions, but what about no solution and unique solution? Let us see. So this is the first case. Now second case is no solution, and last case is unique solution. Okay, so second case is no solution. What will be the condition for system of equations having no solution? Okay, now one thing, remember that when we study the no solution condition in 2D geometry, then we know that when two lines are parallel, and if these lines are represented by a1x plus b1y is equal to c1, then a2x plus b2y is equal to c2, and if these two lines has to be parallel, then the condition will be a1 by a2 is equal to b1 by b2, but this should not be equal to c1 by c2, right? You must have remembered this condition. You must have seen straight lines as well in 11th standard, right? Similarly here also we are going to apply the same condition. If I have two parallel planes, right, two parallel planes, no solution means what? The planes has to be parallel, then only they can't have solution, right? Now if I have two parallel planes, okay, let us say they have two parallel planes, and if I have one more plane as well, okay, just for the system of three equations, then the condition, and if I represent this one as E1, this one as E2, and so let me write it over here. Okay, this is your E1, this is your E2, and this is your E3. So the condition for no solution should be A1 is to A2 is to A3 is equal to B1 is to B2 is to B3 is equal to. When it comes to straight lines, we use fractions, but here we are using ratios because there are three numbers appearing over here, right? X, Y, Z. So that's why here we are using ratios. So for A I have written, B I have written, then for C also it will come C1 is to C2 is to C3, but this should not be equal to D1 is to D2 is to D3. Okay. So this is the condition for no solution. Okay. Now why this condition satisfies? Very simple. If you know a bit of 3D geometry, inside the 3D geometry, if you know a bit of planes, then you must have realized one thing, that among these parallel planes, one thing is same, which is the direction ratios. This thing is actually same for all these three planes. So that's why we are applying this condition. Okay. And if I expand this, so if I box this condition, important one, with green color, okay, yellow color, then this is the important one. And if I expand this, then the condition is that alpha times A1 plus beta times B2, beta times B1 should be equal to, alpha times A1 plus beta times A2, right? Beta times A2 should be equal to A3. Similarly, alpha times B1 plus beta times B2 should be equal to B3, and similarly with C1, C2, C3 as well. Okay, alpha times C1 plus beta times C2 is equal to C3, but alpha times D1 plus beta times D2 should not be equal to D3. Okay, so that is the only thing that I have written over here. Okay, so I hope you understood. When it comes to no solution, okay, that for first three equations it will be equal, but for last equation it will be not equal. Okay, so this is the next case for no solution, where three planes do not have any solution. Okay, now let us look into the last case, which is unique solution. Okay, now if I have a case where the three system of equations have unique solution. Okay, unique solution. Okay, unique solution. Okay, now in this case only one case is possible, where the planes intersect at one point, right? Now I can't represent them in this manner, 3D manner, so I will represent them in 2D itself. Okay, but please do not misunderstand detail line. Okay, so let us assume this is E1, which is plane 1. Okay, and let us assume this as E2, which is plane 2, and this as E3, which is plane 3. Okay, so don't misunderstand this with the line. Okay, this is a plane and I'm showing the side view, the cross section view. Okay, so this will be your E1 and this will be your E2. Okay, now if you see for this unique solution, now if you compare this with 2D, that is straight line part, where you have two lines with A1x plus B1y is equal to C, and A2x plus B2y is equal to D. So what should be condition for unique solution? A1 by A2 should not even be equal to B1 by B2. Now why we are saying this? Because if they are equal, then they have to be parallel or coinciding, but if you see this case is neither parallel nor coinciding, so that's why they are not equal. Okay, if I apply the same analogy for 3D as well, then the logic is that, so our condition is that A1 is to, let me copy the ratio from the previous slide. Okay, yeah, so A1 is to A2 is to A3 should not be equal to this B ratio, and this should also not be equal to C ratio. Okay, now what about with D ratio? It can be equal, it may not be equal. Okay, a similar case with the 2D line as well. So it can be equal, it may not be equal, we do not know. Okay, and when it comes to expansion of this condition, then it should be something like alpha times A1 plus beta times A2 should not be equal to A3, okay, and alpha times b1 plus beta times b2 should not be equal to b3, and alpha times c1 plus beta times c2 should not be equal to c3. Now when it comes to constant, it can be equal, it may not be equal, but we are not bothered with that one. Okay, it doesn't matter, it depends on the question only, but the primary condition is that this should be holding true with the one with white box or yellow box. Okay, so I hope you have understood the condition for infinitely many solution, no solution, and unique solution. Okay, now let us try to solve a pyq. So this pyq I have specified in the chart, so I'm going to skip this and move on to the second pyq. Okay, if you wish, try it out again using the logic that we have learned right now. Now let us move on to the second question. Now second question says, let alpha beta belongs to R such that the system of linear equations, these are the system, has no solution, then beta by A is equal to. Okay, now what we have to do, if I extract coefficient of x, we'll get 1, which is alpha. Sorry, if you have alpha over here, then I'll change it as p. Okay, and here you have 2, so I'll write 2q, and this should be equal to 8. For no solution means these three planes has to be parallel, right? So p plus 2q is 8, and if I similarly do for y coefficients as well, then it's going to be 2p plus q, and this should be equal to 4. If I multiply this with 2, you will get 4p plus 2q, and this should be equal to 8. And if you solve for this equation and this equation, you will come to know that q is equal to 0. P is equal to 0, right? If you subtract it, you'll get 3p is equal to 0. So p is equal to 0, and from here you will get q is equal to 4, correct? 2 times 4 or q equal to 4 from second one. Now if I apply the value of p and q into the z coefficients equation, then you'll get 1 times 0, first coefficient is 1, and second equation z coefficient is alpha, so alpha times value of q is 4, and this should be equal to beta. So this implies beta by alpha, okay, beta by alpha is equal to 4. Okay, now is the answer over? 90% over, 10% not over. Why? Because we also have to check whether this is the D1, D2, D3 satisfy or not. It should not satisfy. If it does not satisfy, then the question is wrong. But let us see. Now 5 into 0 is 0, plus 5 into 4 is 20, and this should not be equal to 18, which is true. So that's why the answer of beta by alpha is 4. Option B is correct. Okay, so I have discussed PYQ for no solution. Now let us have PYQ which summarizes unique solution, infinitely many solution. Okay, no solution. No, there is no option for no solution. Okay, now let us discuss this last PYQ for this video. They are asking you to find out the value of a and b for what type of solution for the system. Now let us see. For unique solution, the condition is that this should be the condition, right? I have shown you over here. This should be the condition. It should not be equal to. So let us see how we can do this. Okay, when it comes to unique solution, unique solution. Now if I assume it as alpha beta, or let me assume it as let's say, okay, let me assume it as alpha beta only. So if I assume this as alpha plus 2 times beta, if I take the coefficients of x, okay, so this should not be equal to 1. Okay, first let me discuss for infinitely many solution, then we can draw the conclusion for unique solution. Okay, so let me discuss for infinitely many solution. Okay, infinitely many solutions, infinite solution. Okay, infinite solution. So for infinite solution, the condition is simple, that if you extract the x coefficient, then it should be alpha plus 2 times beta is equal to 1. And if you do it the same for y, you will get alpha plus alpha plus 5 beta is equal to 2. And if you subtract it, you will get 3 beta is equal to 1, which implies beta is equal to 1 by 3. Beta should be 1 by 3. Now if I substitute 1 by 3 in first equation, you will get alpha as 2 by 3. You will get alpha also as 1 by 3, correct? Yeah, you will get alpha also as 1 by 3. Now let me substitute with the similar kind of equation framing with z coefficients. So alpha times 1, which is 1 by 3, plus a times 1 by 3, which is a by 3, and this should be equal to 3. Now if I cross multiply and subtract by 1, you will get a as 8. So one thing is clear, that for infinitely many solutions, a has to be equal to 8. Now if you look at the options, option B says that, and option C also says that. Now option A is also saying and D is also saying. Now let us see how whether A and D are right or wrong using the last one. Now if I frame an equation with these three numbers, so 6 into alpha, which is 2, plus 36 into beta, which is 12, and this should be equal to B, and this is 14. So we come to know that B is equal to 14. Since B is equal to 14, so one thing is clear, that option B is correct and option C is wrong, because they are saying that B is equal to 16 for infinitely many solutions, which is wrong. It has to be 14. And when it comes to option A and option D is wrong, because this is for infinitely many solutions. Now let us see whether option A is correct or not. Now they are saying A is equal to 8 and B is equal to 16. Now let us substitute and see whether it is right or wrong. Now if I substitute over here, you will come to know that, now if you see that this 14 is not equal to 16, so that's why B is equal to 16 is correct. But if you see, A is appearing as 8, right? But if you remember the condition for unique solution, it should not be equal, right? It should not even be equal. And right, it should not even be equal. Now if you see here, A is appearing z coefficient, and what I have said that for z coefficient also it should not be equal. If you remember that C1, C2 and C3, they are the coefficient of z. Now if you see in this last question, the z coefficient is actually equal to 8, and 8 not equal to 8 is meaningless. So that's why when it comes to unique solution for A equal to 8, it is also wrong. So that's why option A is also wrong. So we are finally left it only and only option B. So that's why option B is the right answer for this question. So I hope you have understood the approach for this unique solution, no solution, and infinitely many solution shortcut. I have explained the logic as well. So I hope you understood the video, and all the best for your JEE Main and JEE Advanced exams. Thank you.